Dear students, I am Santa, working as a physics faculty in Target English Medium School. Today, in this part video, I would like to teach what is the relation between frictional force and area of contact. Is nothing but how the frictional force is depend on the area of contact. Is really the frictional force is depend on the area of contact or not? We are discussing with help of a suitable experiment or activity in this time. So once again listen. So under the concept of factors affect the friction. So in the previous videos we discussed the first two things. What is that one? How the frictional force is depend on the nature of the surface of material or roughness of the material. And the second one is how the frictional force is depend upon the normal force. Now in the same chapter of the friction, now we discuss the third one is also. Our concept is frictional force and what is it one? Area of contact. This is the one. So, is really frictional force is depend on the area of contact or not? We discussed it with the help of this double example. So, listen, all of you, students. If we conduct this experiment, which materials are required to us means a table, a brick, a spring balance, and a thread or a small tiny rope. a tiny rope. These are the materials are required to us to perform or conduct this activity. Now, how we can prove the relation between frictional force and area of contact with help of this experiment we discussed in this time. First of all, we can take a brick. The brick placed horizontally on the surface of the table. So initially the brick we can place where, already I said that, for example, this duster we can say as a brick. Now, so in the brick, this is which one horizontal, it is which one vertical. That's why initially after taking a brick, it is placed horizontally on the surface of the table. After that, now we can take a tiny rope. The tiny rope we can tie to the brick on the both sides, and the thread is connected to the one end of the spring balance, like this one. So initially in the spring balance, what is the reading showing? 0 Newton. Why? Because of you are not applying any force on the spring balance. That is, you know that. That's why initially, okay, after the brick placed on the horizontal surface of the table, the brick is connected to the one end of the spring balance. In the spring balance, the needle will be showing, or the pointer is showing 0 Newton. Now, another end of the circular ring of the spring balance, you can hold in your fingers and slowly try to pull the brick through the which one spring balance, because of you are not directly apply the force on the which one brick, because of between the brick and you what is connected? Spring balance is connected. So that's why, okay, the hook of the spring balance you can hold in your fingers and slowly try to pull the brick through the which one spring balance up to the brick is set into the motion. When the brick is set into the motion, at that time you see the what is the reading showing in the spring balance. That reading you are noted in your mind, or you can note it on the paper. Once again, listen very carefully. First of all, you can take a brick. The brick is placed horizontally on the surface of the table. Now we can take a tiny rope. The tiny rope is tied to the brick, and another end is connected to the spring balance. Initially, the spring balance reading is 0 Newton. Now you can try to pull the brick through the spring balance or with help of the spring balance by increasing the force gradually. Don't pull at a fastly. That's why you can increasing the force gradually up to the body set into the motion. When the body set into the motion, you can see the reading showing in the spring balance, that is you are noted. Let me come. Okay, after that one, now the same brick we placed in vertical mode like this one. It is in which mode? Horizontal mode. It is in which mode? Vertical mode. Again, you can do the same activity. Means nothing but now the brick is placed vertically on the horizontal surface of the table, and a rope is tied to this one. It is connected to the one end of the spring balance, and slowly we can try to pull the vertical brick with help of the spring balance until it is set into the motion. When the brick is set into the motion, you are observing the reading in the spring balance. So already you observing that when the brick is in horizontal way, so how much force is acting means be showing. For example, okay, 10 Newton force is acting on the brick, then it is set into the motion when the brick placed in horizontal position. Like the same way, when the same brick we place in vertical mode and apply the force on the brick up to set into the motion, during such condition also you are observing that how much force, 10 Newton force is applied on the brick, at that time it is set into the motion. Means, so when the brick is placed horizontally, how much force is needed to set into the motion? 10 Newton. In vertical mode also 10 Newton. So that's why what you are understanding here, when the brick is placed in either horizontal or vertical mode, the applied force on the brick to set into the motion is the same, is nothing but the frictional force is also same. When the body is in horizontal or when the body is in the brick, the frictional force is does not changes. So that's why what here, okay, what we can say is that the frictional force is not depend on the which one area of contact, but his frictional force is not depend upon the area of contact. Though it is not right. Frictional force is depend on the area of contact, but which type of way? Here we can say that micro and macro. The frictional force is not depend upon the area of contact, but it is depend upon the microscopic area of contact. Microscopic area of contact. What is the microscopic area of contact? So before going explain this one, once again listen very carefully how we can write during the examination means. So among the two, you can draw only this diagram initially during the examination. That is no need for understanding of you only. I will draw that diagram also. First of all, we can take a brick placed horizontally on the surface of the table. Now we can take a rope. The rope is tied to the brick and further it is connected to a spring balance. Initially, the spring balance will be showing 0 reading. Now we can hold the another end of the spring balance and gradually increase the force on the brick until it is set into the motion. When the brick is set into the motion, you are observed the reading in the spring balance and noted its value. Now repeat the same experiment by placing the brick in vertical mode and do the same experiment and you are observing that. So when the brick is placed either horizontal or vertical position, the applied force does not change. Means here when the brick is in the horizontal position, how much force is needed to set into the motion? Same force is also needed to set into the motion in vertical mode. It's nothing but you know that frictional force is always opposite the motion of a body. Here, when you apply the 10 Newton force, it is set into the motion means what is the meaning? I said in the previous videos, what I said, it is very clear, listen very carefully. When our applied force is greater than or more than the frictional force offered by the body, by the another surface, then the body is set into the motion. Otherwise, if our applied force on the body is less than the frictional force, then what will happen? The body does not set into the motion. If our applied force is equals to the frictional force offered by the body, then the body is ready to set. So that's why frictional force means our applied force less than the frictional force, body is still in the rest position. Our applied force is equal to the frictional force offered by the body, then the body is ready to move on the surface. If our applied force is more than the frictional force, the body is set into the motion. That's why, so in the first case, when you apply the 10 Newton, it's set into the motion means the frictional force offered by the brick is what is that one? Slightly less than the 10 is nothing but 9.99 like that one. Maybe you can set that 10 Newton. Here is also how much one? 10 Newton. That's why, when the brick is placed either horizontal or vertical, the frictional force offered on the brick is the same. But here, how we can understanding the area of contact means, listen very carefully. This duster we can set as a brick. Now here you are observing that this book we can say as a surface of the table. When the brick is placed, the brick is in horizontal position placed on the table. So here you are observing that you draw the boundaries of the brick. Means you know that what is meant by area of contact or surface area means. So the area or the space occupied by an object when it is placed on the another one. The space is occupied by an object when it is placed on the another body. Now here the duster is placed on the surface of the book. That's why this duster will occupy the how much space. So that's why you can draw the boundary. The boundary is represented the space occupied by the duster. So that's why when the duster will be keep horizontally, it is occupied the more area or not, means more space. Now the same duster we place in vertical mode. In this one, it is occupies the lesser area. So that's why what you are changing here. So when the brick is placed horizontally, area of contact is more with the surface of the table. When the same brick we place vertically, the area of contact of the brick with the surface of the table is less. Means here in this experiment we change the area of contact with respect to the table. But in the both cases, what you are observing that the frictional force offered on the body is same when the body is in the rest, the body is in horizontal or the body is in the vertical. Both cases. That's right. After changing the area of contact of the brick also, the frictional force offered by the body is same. Then what he says that the frictional force is not depend on the area of contact, or frictional force is independent on the area of contact, but frictional force is dependent on the which one? Microscopic area of contact. What is the microscopic area of contact means? Here we are observing that. For example, in this one, so according to the area of contact, we are considered this totally. Means when this one placed on the table or on any book, so you draw the boundary. What is the space occupied? That is called macroscopic or area of contact. But microscopic means here you are observing the duster which is placed on the surface of the table. At that time, you are observing that the total entire part is in contact with the surface of the body or not. Now here you are observing that here a small narrow hole is there. That's why when this duster of the lower part of the horizontal we place on the book or my palm, you are observing that are on the table. Okay. So except this part, remaining all the part is directly contact with which one? Surface of the table or book, but this part is not contacted. That's why, but according to the macroscopic, according to this concept, what you are considering, just you consider the total entire area or space occupied. But microscopic means you are considering this part also, means except this part, means which part of the body is directly contacted with the floor, that is the microscopic. But here, so according to the macro or area of contact, you consider the total space occupied, but not consider even though it has a small tiny holes or any parts. But in the macroscopic area, so when the duster is placed, you are not considering all the things, because of here this part, here there is no mass up to here. This part is not contacted. That's why except this part, remaining part only contacted. That is you are considering which one? Microscopic. In case of vertical mode you are observing, when you place this one, in case of area of contact, just you consider that this part. In the microscopic, you consider only this part but not this, because of this, in this part it is not directly contact with the floor. Are understanding or not? That is the macro and microscopic area of contact. So frictional force is depend on which one? Microscopic area of contact, but not the area of contact of macroscopic. So that's why frictional, generally what you can say that frictional force is independent or not depend on the area of contact, but it is depend on the microscopic area of contact. So, dear students, once again listen. Under the factors affect the frictional force. The frictional force is mainly depend on the three following factors. The first one is roughness of the surface or nature of the surface of material. Second one is normal force, and third one is area of contact. The frictional force is depend on the roughness or nature of the surface of the material. That is also very clear. So for that one, we discuss one activity also. So means if the frictional force is depend on the nature of the surface. Which surface will be have the more roughness? It has the more frictional force because of roughness is represented more elevations and depressions. If elevations and depressions are causes for which one frictional force. If elevations and depressions of the height is more, is nothing but more peak position, then what you can say is that it has more frictional force. That's why a rough means if a surface of a body has more roughness, it has the more frictional force. If the surface of a body has the less roughness or is nothing but smooth, it has the less frictional force. That's why frictional force is depend on the nature of the surface or roughness of the surface. And the second one, frictional force is directly proportional on the normal force. Frictional force is directly proportional to the normal force. If normal force is increased, frictional force offered by the body is also increased. For that one we discussed, one brick is placed on the table. First you can pull up to set into the motion. Next another same identical brick we place on the other one, and also you can repeat the same experiment. In both cases you are observing that when in case of a single brick you are apply the 10 Newton means just assume value. When the two bricks you are using, you are apply the 20 Newton. Is nothing but if the mass of the brick is increases, gravitational force is also increases. If gravitational force is increases means automatically normal force is also increases. That's why if the normal force increases, so the force of applied on the body to set into the motion is also increased. Is nothing but indirectly frictional force is also increased. And third one, in this video it says that frictional force is not dependent upon the macroscopic or area of contact, but frictional force is dependent on the microscopic area of contact. So this is among these three, any one of the questions they are asking for 4 marks. That's why keep in your memory. Most I will try my level best experimentally to showing these 3 activities in laboratory. Thank you.